Hello friends, welcome back. In this video, I'll discuss questions on mathematical physics appeared in Assistant Professor Recruitment Exam 2022. The average of the function f of x is equal to sin x in the interval 0 to pi is. Average of f of x is given by 1 by pi integration 0 to pi f of x dx. Here f of x is sin x. Therefore, 1 by pi integration 0 to pi sin x dx. Integration of sin x is minus cos x, so in the interval 0 to pi. So, minus, take it outside, minus 1 by pi, then cos pi is minus 1 minus of cos 0, that is 1. Therefore, answer will be 2 by pi. Option B is correct. The Fourier transform integration minus infinity to infinity e raised to ikx f of x dx of the function f of x is equal to e raised to minus mod x is. Here function is e raised to minus mod x. You just solve this one and find out the value. E raised to ikx e raised to minus mod x dx. Here limit is minus infinity to infinity, but mod x will be positive for positive limits, that is for 0 to infinity, and value of mod x will be negative for minus infinity to 0. Therefore, this becomes e raised to ikx minus x dx for the limit 0 to infinity plus integration minus infinity to 0 e raised to ikx plus x, that is minus of minus x, that will be plus x with respect to dx. Here integration of this will be e raised to ik minus 1x divided by ik minus 1 in the limit 0 to infinity plus e raised to ik plus 1x divided by ik plus 1 for the limits minus infinity to 0. If you simplify this one, you will get the answer 2 divided by 1 plus k square. Therefore, option A is correct. Which of the following matrices is an element of the group SU2? Here 4 matrices are given. So, SU2 group contains only unitary matrix. Therefore, from the definition of unitary matrix, if suppose A is a unitary matrix, then product of A with its Hermitian, that is A Hermitian, should be is equal to I, where A Hermitian is nothing but transpose of complex conjugate matrix. Therefore, A is here, if you consider this one, so 1 plus I by root 3 minus 1 by root 3, 1 by root 3, 1 minus I by root 3, this one is A. Then A Hermitian, that is transpose of complex conjugate. So here if you consider this one, 1 minus I by root 3 minus 1 by root 3, 1 by root 3, 1 plus I by root 3. So transpose means row becomes column, columns becomes row. Here 1 minus I by root 3 minus 1 by root 3, 1 by root 3 goes here, 1 plus I by root 3. Simplifying this one, you will get unitary matrix, unit matrix I. Therefore, here B is belongs to group SU2. The solutions to the differential equation dy by dx is equal to minus x divided by y plus 1 are a family of. 4 options are circles, parabolas, straight lines and hyperbolas. Here one differential equation is given, we have to solve that equation. Let us go to variable separable form. So you have to separate the variables. Y plus 1 dy is equal to minus x dx. Integrating them, you will get y dy integration is y square by 2 plus integration with respect to dy 1 is y is equal to minus x square by 2. Therefore, x square plus y square plus 2y is equal to 0. is belong to family of circles. Therefore, option A is correct. The order of error in the Simpson's rule for numerical integration with a step size h is. So here for trapezoidal rule, error is of the order h square. But for Simpson's 1/3 and 3/8 rule, the order of error is h raised to 4. H raised to 4 is correct. Question is, the probability that two friends share the same birth month is, let A and B be two friends. So consider A, probability to born in any month. So there are 12 months. Therefore, probability to born in any of these months is 12 by 12. Then if you consider B, probability to born in same month, where A born is 1 by 12. Therefore, probability that A and B share same birth month is 12 by 12 into 1 by 12. Therefore, answer will be 1 by 12. Option B is correct. The value of root I plus root of minus I is. So, here we have to simplify this one and find its value. So, we know that by squaring this expression and taking the square root of this one won't change its value. Therefore, so we need to simplify this one. Square of root I plus root minus I. It is a square plus b square plus 2ab. So root I square plus root minus I square plus 2 into root I into root minus I. So root I square is I only. Then square root minus I square is minus I plus 2 into square root I into minus I. That is I square is minus 1 minus into minus, that is plus 1 here. So here I minus I cancels, 2 into 1. Therefore, value is root 2. Suppose refractive index n is given as n is equal to a plus b divided by lambda square, where a and b are constants, lambda is wavelength, then dimension of b is same as that of. Here we know that n is always dimensionless because it is a refractive index. Here given that a and b are constants, therefore dimension of b should be is equal to dimension of lambda square. So we know that dimension of lambda square is length square, that is nothing but area. Therefore dimension of b is same as that of area. A vector perpendicular to any vector that lies on the plane defined by x plus y plus z is equal to 5. So consider this as plane. So if you need to calculate a vector perpendicular to any vector, then you have to take gradient of this plane. That is I dou by dou x plus j dou by dou y plus k dou by dou z. Then our plane is x plus y plus z minus 5. You simplify this one, you will get I plus j plus k. Option C is correct. The equation d square y by dx square plus 1 by x dy by dx plus minus 1 minus n square by x square y is equal to 0 is the, so we know that Legendre equation form, then Bessel equation form, Laguerre equations form, then Hermite equations. So these are 4 equations, and then by comparing this, so it is a Bessel differential equation. If P is a non-singular matrix of order 5 by 5, then rank of P is, so singular matrix means if determinant of P is equal to 0, then it is said to be singular matrix. If it is not is equal to 0, then it is said to be non-singular matrix. Here given that P is non-singular matrix. For any non-singular matrix, rank is same as its order only. Therefore, rank of P is 5. Sij and Aij represent a symmetric and antisymmetric real-valued tensor respectively in 3 dimensions. The number of independent components of Sij and Aij are, here dimension is given, dimension is 3. Then Sij and Aij are symmetric and antisymmetric tensors. Then the number of independent components of Sij and Aij are n into n plus 1 by 2 and n into n minus 1 by 2, where n is a dimension. Here n is 3, 3 into 4 by 2 and 3 into 2 by 2. Therefore, answer is 6 and 3. 6 and 3. What is the angle between vectors P and Q if P cross Q cross R is equal to half Q and Q is not parallel to R? So given P cross Q cross R is equal to half Q and Q is not parallel to R. If Q is parallel to R, that means theta will be is equal to 0. So then Q cross R will be directly is equal to 0, because Q cross R is Q into R into sin theta. Sin 0 is 0 only. Therefore, if Q is parallel to R, then this value will be 0. Therefore, Q is not parallel to R. It is given. Then angle between P and Q we have to calculate. Then consider P cross Q cross R. If you simplify this one, you will get P dot R Q minus P dot Q into R, that is equal to half Q. Comparing the coefficient of Q and R. Here you have to compare the coefficients. If you compare the coefficients of Q, then you will get P dot R is equal to half. Then P dot Q is equal to 0. P dot Q is equal to 0 means magnitude of P, magnitude Q into cos theta is equal to 0. Therefore, cos theta is 0, which implies theta is equal to 90 degree. Therefore, option A is correct. The angle between P plus Q and P cross Q is, so if suppose P and Q are two vectors, then P plus Q is a resultant, always a resultant of P and Q lying in the same plane of P and Q. Then P cross Q is a vector, its direction is always perpendicular to the plane containing P and Q. Therefore, option C is correct. Next question is, consider three vectors. Nu1 is equal to 2i plus k, nu2 is equal to I plus 2j plus 2k, and nu3 is equal to I plus j plus alpha k, where I, j, k are standard unit vectors in a three-dimensional Euclidean space. These vectors will be linearly dependent if the value of alpha is. So, if these vectors are linearly dependent, you have to find out the value of alpha. Linearly dependent means the determinant of the coefficients of I, j and k should be is equal to 0. So, if you consider nu1, coefficient of I, j, k are 2, 0, 1, then for nu2 it is 1, 2, 2, then for nu3 1, 1 alpha. If they are linearly dependent, then the determinant will be is equal to 0. Otherwise, it is said to be linearly independent. So, 2 into, so take the determinant 2 alpha minus 2 plus 0 plus 1 into 1 minus 2 is equal to 0. If you simplify this one, you will get the answer alpha is equal to 5 by 4. Thanks for watching. Hope you like this video. Kindly subscribe and share this video.